Today we are going to talk about tracking the untrackable belt. Regardless of what your role is of belt conveyors, it's important to note that one of the biggest problems with belt conveyors is mistracking. And today we're going to talk about tracking the untrackable belt. So here's what we're going to cover this morning. We're going to talk about the problems of mistracking. So I want to help get you a deeper understanding of the consequences of letting a belt mistrack. Second, we're going to talk about solvable and unsolvable mistracking. So there's a procedure that Martin Engineering has taught for many, many years on how to adjust components to improve belt tracking. And sometimes that works. Sometimes it does not. And we're going to talk a little bit about instances where the procedure works and then what to do when the procedure simply can't overcome the significance of the mistracking. And then finally, as I mentioned earlier, I'm going to preview specifically Martin Engineering's belt tracking device that can help correct belt tracking problems when you've got an unsolvable belt tracking issue. So let's start off with the reasons to resolve belt mistracking. Now, one of our service technicians in Wisconsin in the United States just sent me this photograph maybe 2 or 3 weeks ago, and the timing of him sending this photograph was just incredible. So if you don't know what you're seeing in that photo, I'll point that out to you, but you're seeing the side of a conveyor at the head pulley. In this instance, the belt has mistracked so significantly that it bumped into some structure. The structure then cut the edge of the belt away, causing what you see here. So belt tracking problems often can be problematic. They can be a real hindrance to operations. But in some cases, if left unfixed, they can be catastrophic. And this is an example of a catastrophic belt tracking problems. So one of the reasons that you want to make sure you're reducing belt mistracking is edge damage, preventing damage to the belt. The belt itself is one of the most expensive components of a belt conveyor, and it's critical to protect that belt and have it last as long as possible. So you don't want to damage that belt by letting that belt wander from side to side. Second is citations. So we have recently heard from facilities that we've gone in and done consultation for that they're getting citations when inspectors see cords wrapped around the rollers of a conveyor belt. So if you're walking along your facility and you look at the carrying idler or the return roll, and you see cords from the belt wrapped around that roller. Now, I'm sure nobody here has such an issue going on, but if you do, there's been recently reports of citations from that from safety inspectors. So we've got to recognize that letting a belt mistrack can cause problems that can cause citations from those inspections. Third, and I think probably one of the most problematic things with letting a belt mistrack is the spillage that you'll get at the load zone. If that belt wanders off to the side, the material, as it's being loaded onto the belt, is either going to off-center load or it's going to miss the belt completely. And that's going to cause tremendous amount of spillage. That spillage causes increased cleanup costs, maintenance costs, and it radically increases the cost of operation. And then fourth, the belt can damage structure of the conveyor belt. So that structure of the conveyor is really critical, and we want to make sure that we protect it. Now, I want to share this photo with you. If you look at the bottom right of the screen, you can see where, let me blow this up for you here. 1 second. Let me get you a better look. of this photo. So you can see in this photograph that this belt has wandered and it's rubbed into the bracket that holds the return roll. Now, eventually, that could wear down that bracket completely, causing that roll to fall unexpectedly, which is a huge safety concern. I'll share a story with you that I received maybe a month ago. And there's a company, and I won't say the company. I had one of the safety managers call me up and he asked about guarding a return roll. And he shared with me a story of a return roll that fell from the bracket because the bracket was damaged from belt mistracking and just narrowly missed hitting one of their workers who was down below. So we've talked about belt mistracking can be a problem, but again, we've got to recognize that it can be a catastrophic problem. So let's talk a little bit about solvable and unsolvable mistracking. Now, really, by definition, there's really not instances where a belt can't be tracked. However, I'm going to give you an example of when it may not be in your best interest to solve a belt tracking problem using the procedure that I'll talk about. So, solvable belt tracking, I would define as any mistracking that might be able to be corrected with the roller alignment procedure that we talk about in our foundations book. So solvable belt tracking is where you can use this procedure to correct the belt mistracking. Unsolvable belt tracking, I would define as any mistracking that's either too complex, too costly, or too time consuming to be corrected with this roller alignment procedure. So there's going to be instances where a belt mistracking can occur that's so significant that the operators or maintenance staff simply don't have the understanding, don't have the expertise to implement this procedure. Or the reasons why the belt's mistracking are so expensive that it's not in their best interest to solve all those problems. Finally, there might be instances where you just can't take the time to thoroughly go through this procedure because of its complexity. So let's talk briefly about the roller alignment procedure. So the first step in this procedure is to identify where the low tension area of the belt is. The reason why we want to identify where the low tension area of the belt is because the belt, when under lower tension, that belt has more contact with its rolling component. If the belt's under high tension, if it's under a lot of stretch, that belt doesn't make as thorough of contact with a rolling component. So we're actually more effective with our tracking. We have more influence on the belt when we deal with rollers that are located when the belt is under low tension. Low tension is always after the drive pulley. The reason for that is because the drive pulley grips and pulls the belt, and then the drive pulley, with its lagging, as the belt leaves the drive pulley, that drive pulley pushes the belt away. As that drive pulley pushes the belt away, that belt's under its lowest tension. So first is we identify low tension rollers, and then we basically have workers inspect the tracking of the belt moving in the direction as the belt increases tension. And then third is once you witness a belt wandering from side or the other side, the worker will then move back one roll, shut the conveyor down, lock it out, tag it out, and then make a physical adjustment to the roll previous to where he witnessed the belt mistracking, and then restart the conveyor, observe, and then continue walking in that direction. So it's a complex procedure. To do it correctly takes time, takes expertise. And if there's many factors that are causing that belt to mistrack, it can take a lot of money to solve some of those problems. So the problem with roller alignment procedure is that it really needs some specialized expertise. If your people don't have that expertise, if they don't have the knowledge and understanding and the experience of how to use this procedure, what you'll typically find is guys will just go out and just start beating on rolls with a hammer and cause the belt to adjust, but 2 hours later, 2 days later, that belt's causing another problem with mistracking. The second problem with this roller alignment procedure is that it needs downtime. And if we're running our belts, it's really not a great practice to make these adjustments, because in those instances, we need to break the plane of the conveyor to make those adjustments. So it's really best practice to shut that belt down, locking it out, tagging it out, making those adjustments, and then restarting it. So it's complex. And then the other thing is that it takes a lot of time and it can be repetitive. It can also be minimally effective with complex mistracking. So I want to talk a little bit about the complexity of belt mistracking. There's 13 different reasons why a belt can mistrack. 13 different root causes that can cause a belt to mistrack. If you've got multiples of those reasons happening at your facility, the belt tracking procedure won't overcome all those multiple reasons that you might have going on. So in instances where you might have just one or two small problems with your conveyor that's causing mistracking, this can work. But in a lot of facilities, you'll have 8 or 9 different reasons of the 13 that can cause the belt to mistrack. When the belt mistracking is that complex, this procedure is minimally effective. This is a photograph that we've used for a long, long time in our live classes, and we're going to go through a little exercise here. In this photograph, this belt was mistracking. And you can see they actually, if you don't know what this is right here, this is a 6x6 piece of lumber that this facility wedged in between the stringer or the structure of the conveyor and the belt, trying to keep that belt from bumping into the structure. And it actually rubbed a groove through this 6x6 post. But if we look closely at this, that we should be able to identify 4 reasons, 4 root causes on why this belt's mistracking. So let's talk a little bit about what's going on here. Number 1, it's got carryback. Number 3 is camber. This belt's longer on this side than on this side. And that's why you see this droop on the first side. You see how there's more slack in the belt on this side compared to side B? That's camber. That's because the belt's actually longer on one side than the other. So number 3 is camber. Number 4, a lot of you got this. You did very good on that one. I'm very happy with you. Good job. It's side loading. Number 2, the belt's cupped. So there's lots of reasons. And you can see now with this exercise, you can see the complexity of trying to correct the problem. In this instance, you guys came up with about 12 different things that might be causing it to mistrack. Now, you've got to have people with the expertise to be able to recognize those things and fix those things. I came up with 4, but there certainly might be some other ones. But let's look specifically at the cost of fixing the root cause of these 4 reasons why the belt's mistracking. So the chart that you see shows those 4 root causes that I came up with. Now, your list might be bigger. Keep that in mind. It might be smaller, but you might have, again, 13 different reasons why a belt can mistrack. So the first one was carryback, the second was cut belt, the third was camber, and the fourth was side loading. The root cause problems are on your left. The next column over is the solution to fix those root cause problems. So if we've got carryback, the solution is belt cleaners. The cost in this instance, because of the belt width, for a couple of belt cleaners would be about $6,000. This is a real life instance of a facility who made some adjustments to solve this problem. It took 2 men 1 day to install those belt cleaners. Number 2 was a cupped belt. Once you cup a belt, you can't uncup it. So the only solution to eliminate the cupping of a belt is to get a new belt. In this instance, the price of the new belt wasn't terribly expensive. So it was only a $20,000 investment. I say only, but I say that because, as you probably know, belting can get very, very costly. In this instance, it was only a $20,000 belt. However, it took 3 men and 1 day to do that installation. Third root cause was the belt had camber. It was longer on one side than the other. Camber happens from the belt being stored improperly. Once you get camber, there's no way to eliminate it. It takes a new belt. But at this facility, they already had to buy a new belt because the belt was cupped. So there's no additional costs to resolve this camber. The fourth reason, as you all identified, is that belt was side loading. So in this instance, they had to do some chute adjustments. They had to do some fabricating, and they had to bring in a subcontractor to do that fabrication. It took these guys 4 days. Took 4 guys 3 days to do this fabrication to the chute, and the material cost was $30,000, not to mention the installation. So in this instance, to resolve that side loading, because the way the conveyors were built was pretty complex. So the totals to solve the problem that we saw are pretty costly as they add up. So you got $56,000 worth of materials, and with labor, I'm estimating about $23,000. Now, the cost of labor is going to vary depending on where you're at in the country and the skill level of the people that you're using to do the work. But I estimated with loaded costs that this comes to about $23,000. So let's compare this instance to simply putting a belt tracker on the conveyor and letting that belt tracker do the correcting rather than the staff of the facility doing the corrector. So in this instance, a simple belt tracking product, like you see in the bottom left-hand corner, has a cost of about $3,000. When you compare that to the cost of the equipment and the labor to fix the root cause, that's an almost $80,000 investment. So that's those business cases that you should take into consideration when you're going to either solve a belt mistracking problem or leave it as unsolved and use a product to do the work instead. All right, so what's the downside of a belt mistracker? Well, there's cost involved. There's cost in installing it. You've got to have it come in. You've got to have downtime to put it in. You've got to have guys that can't put it in. But and then there's maintenance on it. And we'll talk about that. But really, that's the downside. It's just like any other piece of performance equipment. It solves some problems. It comes with a cost. It comes with some maintenance. But what you've got to do is make the business case that says, hey, these costs are greater or less than these costs. And at some point in time, you'll find that these belt trackers, like you see on the screen, are a better business case than going through all the procedures that we talked about. So there's trackers for all kinds of belts. You can see on the left-hand side of the screen, there's trackers that can be put on the carrying side of the conveyor belt with a trough idler. We make them for the return side of the belt, like you see in the middle. And one of the biggest problems that we see, and I know somebody was going to ask this sooner or later, is what do you do about reversing belts? And reversing belts are very complex to correct. And that's why we've got a really stout, heavy duty reversing tracker as well. So let me show you a little more. This is a belt tracking device on the carrying side, and how these work is the belt travels across, in this case, from bottom to top. As that belt wanders from side to side, it'll hit one of these guide rolls, either on the right-hand side or the left-hand side. If that belt hits that guide roller will spin a little bit. It's not rigid, it spins to reduce the friction. So that roller spins to reduce that friction. But once that roller gets a little bit of touch from that belt, there's linkage right here that sends a message to make an adjustment to this idler. Okay, so if the belt touches this roller, this side of the idler moves. In this instance, it would move down the screen, which would send the belt to the left. Now, so what this belt's going to do is it's going to constantly move in between these two sensing rollers, and this idler that's bolted onto the unit is going to constantly move, recorrecting the belt. So there's a really tight tolerance between the belt would lay right in here. Here's the trough. That belt would lay right in there, and you leave only about a quarter of an inch between the belt and the roller. This is adjustable, so the width here is adjustable. Let me show you that real quick. Okay, so this piece can slide out to your left, and then with these set screws, whoops, moving too fast for you, I bet. With these set screws, you can set the width of that belt. So you want to install this properly and make sure you've got no more than about a quarter-inch gap between the belt and each of the rollers. This is adjustable for different trough angles. Right, so it's pretty simple. If you've got 20 degrees, 35 degrees, or 45 degrees, you can adjust for different troughing angles with this right here. It's pretty simple to maintain it. You want to make sure material doesn't build up so much on this thing. If it gets caked with material, it's not going to function. So you want to make sure it's kept reasonably clean. And the best way to do that is to make sure that you're doing your job in reducing carry back with belt scrapers. But you can wash this off periodically if it gets built up. The other thing that it needs is it needs a little bit of grease every once in a while. So you can see there's a Zerk right here. There's another Zerk. Try to get it here for you. Back a little bit. So there's your second Zerk right there. And then there is another one on the back side right there. So those 3 grease points need to be greased. We do make a grease kit where your workers, what we do is we basically bring a line out to the side of the conveyor, and that line is connected up to those 3 those 3 Zerks. And you can grease it just from one point from the stringer without shutting anything down. So safe, quick, and easy. You know, what these units are really meant to do is reduce, this is important, gang, these tracking devices are intended to reduce your expertise time and money to solve a belt mistracking issue. This is for those unsolvable. This is tracking the untrackable belt when it's just too complex, too costly, or you don't have the time to do it. This is a better solution. So there's just a little bit more on how this thing works. We talked about that linkage. We talked about how this kind of pivots the roller. You can see in the photograph on the right, that's a tracking device on the return side of the belt. Now, what we'll also do on the return side is we'll make sure that that roll, which can come out of your inventory, or we can supply it, it just drops into our unit. But what we'll recommend is that roll be rubber lagged, because those rubber coated rolls will grip that belt a lot better. There's some specifications on duty rating. There's different duty sizes of these trackers, and that duty rating, there's a standard, a heavy duty, and extra heavy duty, and that depends on the speed of the belt and the thickness of the belt. Most applications in mining or cement production or heavy aggregate is going to take the heavy duty. In some smaller applications, maybe grain, maybe thin belts that are running pretty slow, the standard duty is a better option. But we also have an extra heavy duty that's going to satisfy belts that are over 800 feet per minute and thicker than an inch and a quarter or so. But we can help specify that. This is not a task that should be put on you. So let's talk a little bit about the effective placement of these trackers. We'll talk about their reach as well, but I want to talk about where they should be placed. So somebody mentioned you might need 2. Yeah, you might need 2. You might need 3. You might need 5. It kind of depends on where the belt's mistracking and how significant the mistracking is. If I was going to put these on a facility, I would try to have an understanding of what's causing the belt to mistrack and then use one tracker to see if I can correct that. If that doesn't do it, or I know for certain that there's a couple of locations that are definitely causing a problem, I might add 2 or I might add 3 if I can identify them early. However, I wouldn't apply a bunch of trackers without trying to use as minimal number as possible because of the added cost and adding trackers unnecessarily. But what we'll first look at is we'll look at points A, point B, and point C that you see in this diagram. And the reason why we like these points is because there's lots of problems at what happens just before or just after these points. So the intent of installing trackers at point A is because we want that belt to be running square and centered before it loads. Now, this might be a better location to accomplish that, but in most cases, there's not enough space available. So we choose point A right here and have an expectation that tail pulley is aligned and square properly. If the belt's tracking properly as it enters the tail pulley and the tail pulley is square, that belt will stay aligned as it gets loaded. So that's why we recommend looking very closely at point A. We also want to look very closely at point B. And the reason why we want to use point B is because loading the belt can cause a lot of belt mistracking. So if we're pushing the belt off to one side or the other because of poor loading, then we might want to recenter the load or recenter the belt just after that load or misloading pushes it to one side. So we might put it at point B. Point B might be right here. Kind of depends on your application. Finally, we want to look at point C. And the reason why point C is important is because we want this belt tracking properly just before it discharges, especially if it's feeding another belt. So if I had another belt underneath here that this material was loading onto, I want to make sure I'm centered on top of this belt, and a tracker here helps me accomplish it. Now, that doesn't mean that's the only spots they can go, but those are 3 spots that you want to really take a very close look at to see if that's causing you some problems. I got one more thing I want to share with you, and that's the distance that these trackers have in effectiveness. So these trackers can't completely eliminate belt mistracking. This is important to note. If your belt mistracking is really, really complex, you might need multiple units. But if it's incredibly complex, these can't overcome every belt mistracking problem. So if you've got belts that are wandering off to the point where they're missing idlers completely, and I've seen that happen, these may not completely correct it. They might make an impact, they might make it better, but they might not completely eliminate it. They have some limitations. One of their limitations is the reach that they have. So their reach is about 70 to 100 feet. The further you get from 70 feet, the less effective and the less effective and the less effective those belt trackers can be. So you really want to look, if you've got long conveyors, you might want to take into consideration that, hey, I might need multiples if the mistracking is wildly significant. Have a great day, everybody. Thanks for your time.